everyone, today we will talk about lab motion graph. Let's introduce ourselves. My name is Bubble from Fino 2 number 13.
My name is Gio from Fino 2 number 8.
My name is Fino 302 number 22.
And the introduction. Today we will going to do the lap motion graph. So we will find the motion and do the graph about how fast is the marble.
We predict that the marble will go constantly, and if the slope go higher, the marble will go faster.
Data we use are marble, metal ruler, stopwatch, and video lamp.
Step 1. Drop the marble on the wheel.
Step 2. Start the stopwatch and record the video in slow motion.
Step 3. See the result in making a graph, and this video will show how to solve the velocity.
This graph is the graph we got from the previous video, and we made the other two.
This graph shows that as the time increases, the distance of the marble from the start increases. In the 0 to 0.4, the marble goes to 0.14 meters, and from the 0.4 to 0.8, the distance goes to 0.48, and 0.8 to 1 second, the distance goes to 0.67. As I said before, it shows that as the time increases, the distance increases.
This graph shows that the speed versus time. We use a speed unit in meter per second and time unit in second. At 0 to 0.2 second, speed is 0.45 meter per second. At 0.2 to 0.4, speed decrease a little bit to 0.35 meter per second. At 0.4 to 0.6 second, increase to 0.85 meter per second. At 0.6 to 0.8 second, decrease again to 0.75 meter per second, and at last, at 0.8 to 1 second, increase to 0.95 meter per second, and the average speed is 0.67 meter per second.
Graph acceleration versus time. As the time increases, an acceleration is increased too. But at some point, when the marble hits the wood, the acceleration goes down to negative. At 0 to 0.2 seconds, the acceleration is about 2.25 meters per second square. But at 0.2 to 0.4, the acceleration goes down to negative 0.5 meters per second square. At 0.4 to 0.6 seconds, the acceleration increased to 2.5 meters per second square. And at 0.6 to 0.8 seconds, the acceleration decreased to negative 0.5 meters per second square. And at 1 second, the acceleration goes up to 1 meter per second square. In this experiment, we do the distance versus time, speed versus time, and acceleration versus time graph. We found that as the time increased, the distance increased. And for the speed versus time graph, we found that as the time increased, the speed sometimes increase or decrease. But the average of the graph is as time increase, the speed increase.
The last one is acceleration. We found that in the 0.2 second, the acceleration increased, but in the 0.4 second, the acceleration becomes negative. When 0.6, the time becomes positive, and the 0.8 second, the time becomes negative.
Our hypothesis is 80% correct. We predict that the marble will go constantly, and if the slope goes higher, the marble will go faster. The marble really go faster, but it does not go constantly, so we are only 80% correct.
Our evaluation, next time if we can do this experiment again, we want to fix our problem in the lab. Our problem is the marble may have hit the wall, so the graph of acceleration become negative.
Therefore, it was hard to find the correct acceleration, and the other problem is to watch the distance with the meter ruler more clearly, so the graph will be more perfect.